Welcome to this CPD, Suspended Film Technology for Insulating Glass Units. The CPD is accredited by the Royal Institute of British Architects and brought to you by Crystal Units and HG Dynamic. The content of this CPD will cover company information about crystal units, glazing and thermal insulation, suspended film technology, specifying insulated glazing units with invisible suspended film technology. Project case studies. First, company introduction. Let's watch a video about crystal units.
Crystal units represents the many facets in today's demand for innovative glazing. Having successfully launched several manufacturing facilities located in North London, we are fully equipped to keep up with the ever-increasing demand for high-performance insulating glass units. With over 100 staff members, we strive to innovate the glazing industry. Operating for over 25 years, Crystal Units offer a wealth of expertise, with a creative team boasting impressive technical knowledge, establishing strong relationships with leading glazing specialists, system suppliers and contractors, working together to ensure the finished product is of the highest standard. In order to stay at the forefront of our industry, we continue to research, develop and invest in new plant and technology. One of our latest investments is a laser etching machine. This enables us to create self-heating glass to eliminate condensation in swimming pool areas or provide space heating in large glazed areas such as sliding and bifold doors. With 24-hour production and the capability to manufacture over 2,000 finished products per day on 3 automated production lines with a further 12 processing departments, the fully qualified Crystal Units production team are well equipped to keep up with demand. Supported by our dedicated office, sales and technical teams, Crystal Units are ready for any glass projects. As featured on Channel 4's Britain's Most Expensive Home, we are proud to have supplied our nuclear heated glass, eliminating condensation in the swimming pool and gym partition. Launched in 2016, CUIN Insulating Glass with suspended film technology is the thinnest, lightest and most thermally efficient glazing on the market. With all products certified by the British Standards Institution Kite Mark Scheme and with ISO 14001 environmental and ISO 9001 quality management accreditations, Crystal Units lead the way in safety, efficiency and environmental protection. And with Fleet Operator Recognition Scheme accreditation, we ensure best practice continues even after production. Our aim is to continue to manufacture glazing to the highest standards, introduce innovative ideas to the architectural glazing industry, transfer knowledge and awareness of glazing innovations to industry professionals, continue to innovate and develop environmentally friendly products. Glazing technology is forever advancing, and the only way to keep up is to be a step ahead. Here at Crystal Units, we pride ourselves on being the innovators of advanced glazing technology.
Crystal Units is committed to providing customers with the very best quality and service. The company has been accredited with Kite Mark license for EN 1279 Part 2 and Part 3, Glass in Building, Insulating Glass Units, ISO 9001, Quality Management Systems, ISO 14001, Environmental Management Systems, Construction Products Regulation Attestation Level 1, Compliance with the Fleet Operator Recognition Scheme, Compliance with the Contractor's Health and Safety Assessment Scheme. Today's CPD will cover these learning aims: the need for thermal insulation and the requirement for triple glazing for improved thermal performance, suspended film technology as the new solution and how it works, the benefits of specifying IGUs with invisible suspended film technology and key considerations. Project case studies to further demonstrate these learning points. Let's now look at the requirement of thermal insulation with glazing and issues of triple glazing systems. Why windows? We could just have brick walls. They are cheaper and easier to construct, and you don't get all the complex issues that glass is blessed with. But natural light and a view, even if it's just looking at the building opposite, has been scientifically proven to improve health and well-being, increase productivity in the workplace, and reduce recovery time in hospitals. However, they are also considered as the weakest element in the building envelope. Why thermal insulation? On a global scale, we need to drastically reduce our CO2 emissions. 177 parties, for example 176 countries and the European Union, signed the Paris Agreement on the 22nd of April 2016, following the Paris Climate Change Summit late in 2015. The building regulations provide minimum requirements for many aspects of construction, including those relating to glass and glazing. Thermal insulation in relation to coated glass is covered in approved document L. Double glazing has reached its upper limits in terms of insulating performance, and no amount of low emissivity coatings and gas cavity fills will get the center of double glazing units to lower than 1.0 watts per meter square Kelvin. This requires triple glazing and beyond to improve the thermal performance. However, adding glass layers or reducing the area of glazing and replacing it with walls reduces the amount of light into the building. And natural light is desired as it promotes health and well-being and reduces the demand on artificial lighting. Although triple glazed performance is not within the current legislation for standard buildings, those with highly glazed areas are requiring triple glazing to meet the overall U-value requirements. Projects looking to achieve the best performance also frequently utilize triple glazing. Better thermal insulation means spending less on heating bills and using less energy to heat the building, which in turn helps the environment, and on a personal level, better thermal insulation improves comfort in the home or workplace. By switching to triple glazing, larger glazed areas are again possible. However, triple glazing adds 50% more weight, the insulated glass units are thicker, and there is reduced light transmission. These constraints must be overcome. The solution is suspended film technology. In this section, we'll look at what it is and how it works. Insulating glass with suspended film technology means that a polyethylene terephthalate film is held within the center of the cavity of a double-glazed IGU, creating two chambers, opposed to just one in a standard double IGU. The heat we produce in our homes and buildings is delivered in the form of long-wave radiation. Low emissivity coatings on the inner surfaces of the double IGU reflect heat back into the home or the building. Suspended film technology means that the cavities are filled with a gas such as argon or krypton, which have a low conductivity, helping to reduce heat loss. Also, doubling the chambers with low E coatings effectively halves the heat loss. The thermal performance of a double IGU with suspended film technology is comparable with standard triple glazing, but can be even better. There are two types of suspended film available. We can see here. The first is a solar control and low emissivity coated film, and the second is an uncoated transparent film. First, we will look at coated films in more detail. Coated films have been around for decades and are limited in their performance. The maximum width of the film is 1,800 mm due to the size of the magnetron coater, and the coatings have a distinct pinkish colour. The technology of the coatings is not as advanced as those on glass, so the solar control and thermal performance is limited. Also, because the coating is on the film, it's not possible to utilize the high-performing glass coatings. These low emissivity and solar control coatings also lead to visual distortions on the film. Applying coatings to any material will alter its reaction to solar radiation, essentially increasing the solar absorption. When the sun's short-wave radiation hits the film, a large proportion is absorbed, causing it to heat up and expand ever so slightly. During the night, the film then cools and contracts. This repeated action of expansion and contraction over a period of time can cause the film to wrinkle. We will now look at the second type of suspended film available, transparent uncoated film. Unlike coated films, transparent uncoated films have virtually zero solar absorption. When the sun's short-wave radiation hits the transparent uncoated film, it is transmitted directly through and is not absorbed by the film, negating any rippling over time. Added protection comes from the low E or solar control coated outer pane, which reflects or absorbs some of the short-wave solar radiation. Transparent uncoated films are the high-performance option superior to both triple glazing and coated suspended films. Because transparent uncoated film utilizes advanced architectural glass coatings, combined with specialist factory processes, the lowest U values are possible, meaning there is less heat loss and less waste. It does this while maintaining maximum light transmission with very low levels of solar heat gain. Transparent uncoated films are not limited to the size of the magnetron coater, so the maximum size is currently 3000 by 6000 mm as standard. Minimal absorption of the sun's shortwave radiation means zero distortion over time. Transparent uncoated film is compatible with all glass coatings, so any glass coating can be used to achieve the desired performance or aesthetics. In this section, we'll focus on the specification of IGUs with uncoated transparent film, the invisible suspended film technology. Invisible suspended film technology is specified because its thermal performance drastically improves the U values of both double and triple glazed units. Its low weight and thickness mean that installation costs can be reduced with less labor and by removing the need for lifting machinery. The thickness means that standard frames for double glazing can be used, and existing frames can be replaced easily. Its environmental benefits result in greater reduction of CO2 emissions during manufacture, transportation, and when it's in service. Finally, its acoustics mean that specifying suspended film technology provides better sound insulation. It should be noted that despite having these additional benefits, the safe handling and installation advice is the same as other standard IGUs. For example, always follow the manufacturer's instructions, inspect the cut edges for excessive flaws, check all surfaces for any signs of mechanical damage or etching, and store it safely to ensure there is no risk of injury, etc. Similarly, when specifying supporting materials such as fixings, adhesives, and sealants, this is done in the same way as any other IGUs. Follow manufacturer's recommendations. The invisible film between the two panes of a double-glazed IGU splits the cavity into two chambers, which, when combined with low emissivity coated thermal insulating glasses and filled with an inert gas, achieves unparalleled thermal insulation compared to any standard double or triple glazed unit. The table and diagram here show the typical thermal performance of this unique technology. You can see that IGUs with invisible suspended film are superior in thermal performance and are the most thermally efficient insulating glass unit available on the market. They achieve the lowest U values available today. Thus, they result in less heat loss and lower energy bills. The building regulations provide minimum requirements for many aspects of construction, including those relating to glass and glazing. The most important in relation to coated glass being thermal insulation in approved document L. For example, current building regulations state that when renovating or extending a home, the glazing elements must have a UW value of 1.6 watts per square meter Kelvin or better. And for a new build house, the glazing cannot have a UW value worse than 2.00 watts per meter squared Kelvin. Please also note that CIPC TM59, entitled Design Methodology for the Assessment of Overheating Risk in Homes, requires overheating risk assessments to be based on 24-hour occupancy and urges designers to carry out noise and pollution assessments before assuming a building will be naturally ventilated. Building regulations requirements for glazing and UW values are always stated for glass in a vertical position. However, when specifying glazing, heat loss increases immensely with inclination from a vertical to horizontal position. A standard double-glazed unit will achieve 1.0 watts per meter squared Kelvin in a vertical position, rising to 1.4 watts per meter squared Kelvin at 45 degrees, and 1.6 watts per meter squared Kelvin when horizontal. Therefore, when moving from the vertical position, the heat loss could be considerably higher than first thought, possibly not meeting regulations. A potential option is switching to triple glazing, but the additional weight is definitely not desirable. The suspended film technology is the ideal solution to meet the U-value requirements. As the diagram shows here, double glazing with suspended film technology achieves 0.4 watts per meter squared Kelvin when vertical, and only rises to 0.7 watts per meter squared Kelvin when horizontal. Another benefit and standout characteristics of IGUs with suspended film technology is the weight reduction in comparison to the equivalent traditional IGU. Glass has the same density as reinforced concrete, so any reduction in weight can have an enormous effect on the building. Compared to a standard triple-glazed IGU, double glazing with suspended film technology is approximately 15 kilograms per meter squared lighter. So what does this mean? Well, the weight of triple glazing can cause deflection of overhanging slabs, brackets on unitized systems, or can exceed transom weight limits. Weight saving on the facade reduces the need to reinforce structures on the edge of the slabs to limit deflections and results in super thermally efficient facades with large glazing units without needing to reinforce the transoms. If we think of the bigger picture, installation costs can be reduced with less labor and by removing the need for lifting machinery. Also, replacement panes will be lighter, so building maintenance units can be utilized when undergoing maintenance to avoid road closures and cranes. Sliding doors can be difficult to operate and need a lot of force to get enough inertia to move, especially when triple glazed. Sliding doors also only allow a very small movement tolerance to ensure that they slide freely. Consequently, with triple glazed sliding doors, the tracks quite often need reinforcing. It is generally unknown who is going to occupy a unit. Therefore, use by disabled occupiers must be considered. Consequently, in a development where all the units have triple glazed sliding doors, a motor is often installed to all units, and this can be very costly. IGUs with suspended film technology mean that ultra-low U-value sliders are now possible that can be easily operated by all without motors. Tilt and turn windows are no heavier than double glazing, removing the need for unsightly barrel hinges. as well as being easily operated by all building users. With suspended film IGUs, larger sizes are now available that previously would have been too heavy for many systems. One of the glass panes in triple glazing can be replaced in suspended film IGUs. This glass pane is generally 4 mm or thicker, and by manipulating the gas fillings, suspended film IGUs are up to 36% thinner than triple glazing. This means that standard frames for double glazing can be used with suspended film IGUs, which can enable a real cost benefit. Frames are often limited by the IGU thickness, and with thicker triple glazing IGUs, the combination of thickness and weight often results in the framing system being unable to carry the unit. Glazing in existing frames can be replaced in refurb projects to get a marked improvement in thermal performance, since passive IGUs result in half the amount of heat loss of double IGUs. An independent study was carried out reviewing the benefits of the suspended film glazing technology for domestic buildings. The study includes the assessment of predicted energy consumption, CO2 emissions, as well as embodied carbon. In addition, the impact on occupants' thermal comfort is investigated. The assessment includes a comparison of both double and triple glazed units. As shown in the table, the results show that the domestic improvements on the predicted operational energy can be significant when focusing on metrics such as heating demand and heat cost savings. With regards to thermal comfort, the units create more isolation from the external environment and minimize heat loss from the spaces. Depending on natural ventilation and cooling, this tends to slightly increase overheating risk when using the initially specified G-value performance. This can be remedied by specifying a lower G-value glazing. Due to the suspended film glazing unit's superior U-value performance, it still maintains excellent savings in the predicted operational energy savings. This study was prepared in line with the EN standard 15804 by reporting the Environmental Indication Global Warming Potential, or the so-called embodied carbon. EN 15804 is the EPD standard for the sustainability of construction works and services. Environmental Product Declarations. Core rules for the product category of construction products. The study outcomes show that from cradle to gate, the double-glazed unit is 5% less carbon-intensive than suspended film DGU, whereas the triple-glazed unit is 31% more carbon-intensive than suspended film DGU per meter squared. Suspended film glazing outperforms standard DGU in carbon emission in service. Standard double glazing results in 1.0 watts per meter squared Kelvin heat loss, whereas double glazing with suspended film technology results in 0.4 watts per meter squared Kelvin heat loss, which is 0.6 watts per meter squared Kelvin better. This reduction in heat loss means that 18 kilograms of CO2 is reduced per meter squared of glazing per year due to the lower energy demand on the heating system. Triple glazing with suspended film technology results in 0.2 watts per meter squared Kelvin, which is 0.8 watts per meter squared Kelvin better than standard double glazing. That's 22.5 kilograms CO2 reduced per meter squared of glazing per year through lowering energy demand on the heating system. Consequently, IGUs with suspended film technology result in a reduced cost of renewable energy sources and a reduced cost of maintenance of renewables. IGUs with suspended film achieve enhanced sound reduction properties, as the film is a sound wave absorbing material. In these tables, we can see the weighted sound reduction index, RW, of each construction type of IGU, measured in decibels. This is the level of sound insulating abilities of walls, floors, windows and doors. It is clear that in both toughened and laminated glass, the suspended film IGU achieves the highest RW figure, meaning that it provides better sound insulation. The invisible film is only microns thick. It is the same weight and thickness as standard double glazing, meaning that the suspended film IGU achieves greater acoustic performance with the same thickness as standard glazing. IGUs with invisible suspended film technology have achieved many certifications, including the BSI Kite Mark license, proving that they meet the optimum standards for quality and reliability for BS EN 1279 Part 2 and Part 3, glass in building, insulating glass units. IGUs with suspended film technology have also been assessed in accordance with BS EN ISO 12543 Part 4, glass in building, laminated glass and laminated safety glass, test methods for durability. BS EN 673, glass in building, determination of thermal transmittance, U value, calculation method, and BS EN 410, glass in building, determination of luminous and solar characteristics of glazing. Finally, IGUs with invisible suspended film technology comply with the IFT guideline. Thermally improved spacer, Part 1. Capabilities of IGUs with invisible suspended film technology include: the glass substrate can be annealed, laminated, heat strengthened, thermally toughened, and heat soak tested. The maximum size is 3000 mm by 6000 mm. They can also have a polyurethane or silicon secondary seal, providing structural integrity and functioning as a barrier to water, air and other substances. IGUs with suspended film is suitable for structural silicone glazing and can be clamped. They have a warranty of 10 years. But the product's average service lifespan is at least 25 years, as with standard IGUs. The film is made of a biaxially oriented polyethylene terephthalate, which is recyclable. So, providing that the IGU is dismantled, the glass and film can both be recycled. It should be noted that all IGUs must be dismantled prior to recycling to separate the spacer bar and the sealant. Packaging. The film is wound on a cardboard roll, which is recyclable, and therefore reduces the need to extract new raw materials, contributing to sustainability. The suspended film IGUs are delivered on timber or steel stillages, which are then returned for reuse, again saving the energy needed to remanufacture or extract products. The government's official guidance rules on fire safety. Approved Document B, Volume 1 and 2, define products achieving an A1 classification as non-combustible and products achieving an A2 classification as being of limited combustibility. A-class products make no significant contribution to fire growth, while products with a rating of B to F are classified as combustible. The Building Amendment Regulation 2018 applies to relevant buildings at least 18 metres above ground level. It requires that all materials which become part of an external wall or specified attachment achieve Class A2 S1, D0 or Class A1 other than those exempt. The Building Amendment Regulations 2018 do not apply to a list of components found in external walls and specified attachments, including window frames and glass. IGUs with invisible suspended film technology can be used as facades on buildings over 18 metres, and like the interlayer in laminated glass, is permitted when within a window. There may be cases where IGUs with invisible suspended film technology are fitted in spandrel panels, which form part of a curtain wall on relevant building types over 18 metres, Such panels in certain walls are not exempt in Regulation 7(3) and therefore must comply with Regulation 7(2). If in doubt, seek specialist advice or clarifications from specialist fire safety consultants. For the installation of IGUs with suspended film technology, adhere to manufacturer's instructions and BS 8000 Part 7, Workmanship on Building Sites, Code of Practice for Glazing. Where work at height and access equipment is required for the site, care should be taken to provide safety measures such as scaffolding and PPE to prevent any person falling or being struck by a falling object under the general principles of Regulation 9.2 of the CDM Regulations 2015. Building Regulations Approved Document K4 covers protection against impact with glazing. It identifies critical locations for safety glass for all buildings. Glass manifestation makes the glass visible, preventing injury through collisions. It can also help enhance privacy and can be decorative. Guidance on this is covered by Buildings Regulation Approved Documents M and K5.2. Here are some projects where IGUs with invisible suspended film technology have been specified. Queen Mary University, Mathematics Building, London. The challenge was a miscalculation in the amount of space required behind the spandrel panels for suitable insulation to be installed occurred. There was not enough room to install thick enough insulation to bring the overall building U value down to specified levels. IGUs with invisible suspended film were used in place of a standard insulated spandrel panel and insulation. With a U value of just 0.2 watts per meter squared Kelvin, no insulation was required to be installed behind the panel. Subsequently, the building passed its U value requirement. The Forge, Upton Park, London. The challenge was triple glazed U values were originally specified by the architect. However, the maximum unit thickness into the chosen sapper system was 36 mm. IGUs with invisible suspended film helped achieve the specified U value, whilst also being narrow enough to be compatible with the sapper system, achieving a unique solution not procurable elsewhere. A few more examples of projects where IGUs with invisible suspended film were specified. Luma House, King's Cross, London. Luma has been designed to take advantage of the parkside setting, creating elegant apartments benefiting from floor-to-ceiling views over the surrounding greenery and the delight of natural light, evoking a sense of escape from the modern city world. Keybridge Tower, London. Through the use of mixed brick tones and textures, each building at Keybridge has a distinctive character designed to improve over time as London's regenerated Vauxhall enters a new era. Callis Yard is a new community that combines engaging heritage buildings with distinctive contemporary architecture. The apartments and the old stable conversions create a vibrant, new and contemporary community close to the Thames. Learning outcomes. We hope you have achieved the understanding that, by incorporating an invisible suspended film within the cavity of a DGU, the glazing is thinner and lighter than traditional triple glazing units. The low weight characteristics enable thermal insulation without compromising on pane size and natural light. It offers many environmental benefits, such as reduced energy consumption and carbon emission. Thank you for watching this CPD. For project support, please contact our Concept Director, Adrian Gallagher, using the contact details on the screen, or visit www.concept-director.com. crystalunit.com for more information.